So suppose you're giving this function, a function dependent on DCVA and with that list of minterms. When you're given the liberty, you can choose where to put the variables. My recommendation would be to follow a specific pattern. The best pattern that I can think of is 0 here, now if I choose that pattern, that means that the least significant bit, which is the variable a, that variable it's the jump from 0 to 1. So the jump from 0 to 1 is by jumping this border here, so that means the variable a should be here. Then the other one would be the variable b. Where is variable b? Where I have the jump from 0 to 2. And the jump from 0 to 2, it's done by jumping this edge over here, this division. So letter b should be here. C is where I have the 4. So the 4, it's over here, where I jump from 0 to 4. And that jump, it's by crossing this line. So that means that the variable c must be here. And finally, the 8 is achieved by jumping in the top, and that is jumping this section over here. So that means that variable d should be here. So that means, again, variable a should be here, variable b should be here, variable c should be here, and variable a should be here. This is if, this is variable d. This is if and only if we want that specific numeration of minterms. So by doing that, we say that minterm 0, it's a 1. So we have a 1 here. The 1 is also 1. The 2, the 4, the 5, the 7, the 8, the 10, the 11, the 14, and the 15. So that means those are the ones of the function. So how do we solve this problem? Well, first, remember, the algorithm says that we need to try to group as many ones as possible. In this exercise, there's no way you can group 16 ones together. So we try to find 8s, groups of 8s. And we also don't have groups of 8s. So we go with groups of 4. So I have one group of 4 over here. And one thing that I would recommend you is that you use this numeration. This means that we have the first group. This is important because it tells me which groups you find first. And again, the first group you find must be the ones with the most amount of ones. Then I have a second group over here of 4. So this would be my group number 2. Now, you may think that these are all the groups of ones, of 4 ones that you have, and you might make the mistake of trying to find groups of 2. Our recommendation is when you're trying to find groups of 4 or any number of groups, focus really hard on trying to find those numbers. And I tell you this because I know in this case that this one is adjacent with this one, with this one, and with this one. Hence, this is group number 3. And I'm going to put this number 3 in all the sections of this group because it's separated, at least visually. So I have 3 groups. Now my question is there any other group of 4 ones? And the answer is no. So we proceed to finding groups of 2. And you might make the mistake to think that maybe this one is a group of 2. Now this is where I tell you, don't be redundant. This group of 2 is already grouped by a group of 4 ones. So don't do this. However, there is one group here, which this would be my group number 4. And there's also another group here of 2, which would be my group number 5. The next part is trying to find the asterisks. The asterisks are all those ones that are grouped by only one group. In this case, this one has an asterisk. This one also has an asterisk. This one here also. And this one here. This one here, and this one here. That means that the solution must include group number 1, group number 2, group number 3, and that's it. Those 3 groups must be part of the solution. Groups number 4 and groups number 5, they are not, or they may not be part of the solution. So what you're going to say is, if I have to choose those groups, I'm going to cross all the ones that I have already taken into account. So for example, group number 1 takes this one, this one, and this one. Group number 2 takes this one, this one, this one, and this one. And group number 3 takes this one and this one. So that leaves me with just 1, 1. So the question is, how do I group this one that it's being left? There are two possibilities. I either choose group number 4 or I choose group number 5. So this particular problem has two solutions. The solution would be plus, and then I have two options. I either choose group number 4 and group number 5. Once I do this, I must write what those groups' expressions are. So for example, group number 1, its expression, it's equal to, and I start by the order in the variables. So I start with D, letter D, it's D inverted. Letter C crosses the group, so it must disappear. Letter B, it's V inverted. And letter A, it cuts the group. So that's it. Then group number 2. Well, group number 2, it's going to be DV. Then group number 3, it's going to be C inverted, A inverted. And finally, group number 4 and group number 5. Each one of those has a different expression. And group number 4 would be C, B, A. And group number 5 would be D inverted, C, A. And this would be the solution of this problem. Again, this problem has two solutions. It's group number 1 plus 2 plus 3 plus either 4 or 5. Now let's see a Maxterm example. In this example, you can see that the letters, the variables have changed. And of course, we have a different list of Maxterms. And we're going to use the same numbering. So we're going to have 0 here. Now, one thing I do is I put only the numberings on the top part. And then I just put the beginning of each row. That helps me better localize the Maxterms. So in this case, I have a 0 here. So I have those zeros. So we start by grouping, and we can't find any groups of 8. So I'm going to go with groups of 4. And I notice that there are no zeros left to group, so there is no point for me to try to find groups of 2. So now let's go with the asterisks. So we can see that each group, group number 1, group number 2, and group number 3, each of them have zeros with asterisks. That means that there is only one solution and all the 3 groups must be part of that solution. If I take the group number 1, the group number 1 covers this 0, this 0, this and this. Group number 2 covers these 2 zeros, and of course the other zeros that were already covered. And group number 3 covers this one and this one. So the solution is pretty simple. The solution is going to be function, it's going to be equal to 1. Now, since this is Maxterms, it's going to be dot 2 dot 3. And now let's take the functions. And here I have made an omission because I put the numeration, but I didn't put the variables. And now that I have to put the functions, well, of course I need the variables. So I'm going to put the variables first. The 1, it's the least significant variable, and that's going to be here. The 2, it's the C, and the C is going to be here. The 4, and the 4 is going to be here. And for the 8, well, that means that the 8 is going to be here. So that's the location of the variables if I want that specific numeration. So now that I have the variables, I'm going to go with group number 1. So group number 1, it's equal to, it's on the area where C is equal to 0 and where A is equal to 0. So since they're both 0, I don't need to invert them because that's the only way the function is going to give me 0 in that specific combination. So this is like the opposite. If you have an area where the a is not present, that means that a is 0, and since you want zeros, you don't invert the variable. Rule number 2 would be C or D inverted. And that's because we have rule number 2 where D is equal to 1. And if D is equal to 1, this expression would give me 1, and I want a 0. And finally, rule number 3 would be V or D inverted. So this would be the minimum expression for this function.